Okay, then, welcome to the final talk of DBTest. Welcome to the presentation of our short paper, Workload Merging Potential in SAP Hybris. For this paper, I collaborated with Martin Kepner from the TU Munich, Professor Lehner, Professor Binnig, and Anne Schwarz from SAP. In OLTP systems, we often run into the cases that we face overload spikes in our systems. One example was presented last year at SIGMOD by Alibaba. There they presented that the number of incoming transactions increases by a factor of 121 from 1 second to another on Chinese Singles Day. They call this the transaction tsunami, and it is depicted by the red line in this plot. Of course, Alibaba puts a lot of effort into optimizing the system and put a lot of money into acquiring additional hardware to keep the response time steady during these high peak scenarios, as depicted here in the blue line. Another example is Amazon. Amazon in the Christmas time faces an increase of page views, which is then reflected in the sales that we see here. And as Alibaba, Amazon is also spending a lot of money into acquiring additional hardware to overcome these high peak overload scenarios. So the question we face is whether we could optimize the OLTP workloads to face or to flatten these overload spikes without acquiring additional hardware. And 2 years ago at VLDB, we submitted OLTP share. We submitted our idea. We had two hypotheses. So the first hypothesis was that workloads are read heavy and consist of a few statement strings that are frequently submitted by multiple clients. So we analyzed a lot of open source projects and found that 90% of all the open source projects use less than 10 different read statement strings. And the idea we proposed then was that if we merge these statement strings by inflating the parameter list, we can execute a merge statement, can retrieve an intermediate result, which we can split and hand back to the requesting clients. Our second hypothesis was that if we apply such merging technique to a synthetic benchmark, as you see on the right-hand side, we can increase performance in overload scenarios by a factor of 2. Now, in this short paper, we wanted to confirm these two hypotheses for some enterprise workload. And unfortunately, we could not get our hands on an Alibaba workload or on an Amazon workload, but SAP has acquired Hybris, and Hybris is a platform for over 160 retailers, labeling it one of the leaders in e-commerce. Hybris is a multi-level tier system, so clients connect or send their requests over the network to some server running an Apache Tomcat on top of Solar Page Cache and the SAP HANA database system. And in our experiments, we simulated these clients by some JMeter threads, and 80% of these JMeter threads were running a browsing workload. So they land on a homepage, they search for products, search for categories. 15% of all the clients would additionally then add an item to the cart, and the remaining 5% of all the clients then actually buy the item. Now, one would maybe say that a 5% conversion rate appears to be very high, but this is exactly the workload that the colleagues of Hybris are optimizing the system for. So we think it's a good idea to get along with this workload. Regarding the first hypothesis, we executed the described workload and traced the statement on the database side. And we ordered the statement by their execution frequency. The statement with rank 1 is the most frequently executed statement. And we accumulated the total execution time of the statements. So what we get from this plot is that the 20 most submitted statements make 80% of the workload's execution. So 20 statements are responsible for 80% of the execution. As we group statements by the statement types, we find that 80% of all the statements are single select statements and 12% are range lookup statements. So overall, 92% of all the statements are read statements. 3% are commits, and the remaining are DML statements. So all in all, we see that SAP Hybris is indeed a read-heavy workload with a few hotspot queries, and this confirms our first hypothesis. Regarding the second hypothesis, we executed some ODBC benchmarks. So we have 300 clients that in a loop execute like the same query to the database. And first of all, we took a very simple key lookup query and merged only a certain percentage of all incoming queries. And that percentage is reflected on the x-axis of the plot. And we measured the throughput when merging, and we measured the CPU, and we compared both to the baseline and give it here in relation to the baseline. So one means that we have no improvement, and for the throughput, higher is better, and for the CPU, lower is better. And what we take away from this plot is that when we merge all of the incoming key lookup queries, that almost half of all the CPUs are performing twice the throughput, which is a very good result. And we did this for statements of different complexity, so for a union and also for a joint query. And the main takeaway from this slide is that regardless of the statement's complexity, all statements benefit from merging in terms of throughput and CPU. And for the next experiment, we just merge the key lookup query on the left-hand side in an end-to-end scenario. So we want to know what is the improvement of merging in a full end-to-end scenario in a system layout as described earlier. So for this example, we increase the number of JMeter threads from 100 to 900 and plot the results in clicks per second. And as expected, once the system is satisfied for 400 JMeter threads, the baseline drops. So this is the overload scenario that we are talking about. Now, as we just apply merging to one of these queries, so this lookup query that we had on the previous slide, we can increase throughput by 20%. So the takeaway here is that merging improves throughput by 20%, which then confirms our second hypothesis. So to put it in a nutshell, in this paper, we had two evaluation questions. The first was regarding workload characteristics, OLTP workload characteristics. The hypothesis here was that OLTP workloads are read-heavy and have a few hotspot queries, which are frequently submitted by multiple clients. In SAP Hybris, the analysis showed that 80% of all submitted statements are single select statement strings, and the 20 most frequently submitted statement strings make 80% of the workload's execution. The second evaluation question was regarding the throughput improvement by merging. The hypothesis here was that we can increase throughput by a factor of 2 for a synthetic benchmark. We showed this in our ODBC benchmark for sample statement strings. We also showed that we can improve CPU consumption by 50%, and that in an end-to-end scenario, the throughput is increased by 20%. And this also confirms our second hypothesis. So if you have any further questions, you can ask in Slack, you can read our paper, you can install Hybris, or you can drop me a mail. Thank you very much and have a nice weekend.
Thank you, Robin. Any questions? So Robin, you briefly mentioned that you're only sharing one query in this workload. would you envision if you share different query types, then the performance even gets better, or what was the motivation?
The motivation is that when we have a look at the 20 most frequently submitted statement strings, some of these are of rather complex type. And the one we merged is a very simple one, which is rank 4. So it's the 4th most frequently submitted statement. So for the first 3, it's maybe too complex to implement those. And for the others, the throughput improvement might be too low. So I think we got the best out of the workload.